Hello everyone, welcome to Communication System Lab. I'm going to just quickly go over the equipment as well as the software. So the equipment we are using in this lab for Communication System Lab is called Unitrain System. It includes a module that we call it the interface, which is the one that gets connected to the computer using a USB connection. And then these are for the power supply that they go to the transformer to provide the power for the unit. The interface has two channels, channel A and channel B. These are our oscilloscope channels for monitoring, and this is output for the function generator. So this analog out is going to give us a signal to be outputted to anywhere on the board. Then we have the experimenter modules. The experimenter modules, we have two of them that are identical, and those are the modules that we should insert the board inside the experimenter and do the wiring and connect it to the interface. So where do we get these boards from? Every lab has a suitcase, every experiment. So for example, this suitcase is for AM, FM modulation. So you open it up, and then I'm going to show you how the software is showing you which boards you need to insert inside the experimenter. So we put the board inside the experimenter, and now we need to run the software. So for the software, you need to search for LabSoft. So I'm going to type LabSoft, and you see LabSoft is going to appear on the top. So click on it, and then I am going to change, create, let's say I am a new user. So let's say I'm going to say Masood. I hope the account for Masood is not going to be there, but for password, leave it as blank, say okay. And it's asking me, do you want, this account doesn't exist, do you want me to register it? You say yes, and then you click on the telecommunication and you say okay. So on the left side, the list of 4 categories of filters: PAM, PCM, delta modulation, digital modulation, and analog modulation pops up. For first one, for the AM, we need the analog modulation, and we need to click on AM. So these are list of experiments that are available for the AM. The one that looks like a yellow page with a pencil, these are the experimenter. There are some mathematical description that you can see for the AM. It explains some stuff from AM, which is good. And there are some theoretical, for example, here it explains the modulation depths and some theory about the modulation depths. And finally, the principles of AM is one of the experiment. So if you go there, you can see the type of boards that you need. So if you look at it, it shows a board with 3 potentiometer. You can see the board with 3 potentiometer, and then also a board with 1 potentiometer. It also explains the, during the software, the beauty of the software, explain exactly the name of the boards. So I already have, this is the board with the the potentiometer with the 1 potentiometer middle. This is the board with 3 potentiometer. This is our Hartley oscillator, which is, or Colpitt's oscillator, depends which one you want to use. So this gives us the carrier frequency. So this is a carrier frequency generator. This one is our AM modulator on the top, and the AM demodulator circuit in the bottom. Make sure the board is all the way to the end, and you can hear the clicking sound. I also wanted to explain a little bit on the boards. So this board is our carrier frequency oscillator. So the output of the carrier frequency is the one that you say 1 to 1. So this yellow wire is output for the carrier frequency, and this knob is the knob that you use to fine-tune the frequency of the carrier. So then on the modulator part on the top, you see there are 2 signals. The yellow wire is connected to something called oscillator. This is carrier frequency. So the oscill input that you see connected to the yellow wire is carrier frequency, and it should come from this board. You see the connection from this board, carrier frequency goes to there. Then for this one, it says NF in. This is a low like a frequency signal, or basically our message signal, and it's coming from the function generator. So you set the function generator to give you the signal which is supposed to be modulated by the carrier frequency, and then your output of AM is coming from this. What I need here, I'm going to run it all the way like to the end. So if I play it, then it shows exactly what are the, so it says there is a jumper here, so you have to put, and let's run it completely. So it's showing that you need to put a jumper over there, and then it's showing then you need another jumper here. So two jumpers are shown. You have to do then one wire from channel A, so you see channel A plus to the signal here, and then the channel A minus goes to the ground for the like function generator, and it goes to the ground here. So I lost it. You can pause it here if you want. So pause it anywhere that you want, you can just pause it. So I can see the wire. So the wirings are done here, and this is the wiring, type of wiring we do here. We have a wire case, so feel free to use it. And these are our jumpers, so you can use the jumper. So you can see the two jumpers that was shown in the like thing. One was here, and then there was another one that I see that I'm missing here. And if I go, I can see the jumper in the middle. I don't know if it's showing well or not, but this is the jumper here. So you see the jumper here in the middle. So I have to grab one of the jumpers and bring and put it here. So I put the jumper here to make sure that I have that right. So going back to the software, after you see you see the wiring diagram, it gives you some instructions. Set this frequency, set this actually the voltage, and these are the things that you need to do with the oscilloscope. And I'm going to show you how oscilloscope is working. And it gives you some settings for oscilloscope, which we're going to go there, but I want just to jump to the part that AM signal is going to be seen. So for AM signal, you need to set the function generator first. So when I click on this one, this menu, which is the function generator, popped up, and look at the setting. It says sine wave. So I already have it on sine wave. It says 1 to 10 and 20%. So this is setting for 1 to 10, 20%. I have to go this all the way to, it's going so fast. So I'm going to that. And then it says 10 kilohertz. So for 10 kilohertz, I'm going to click on, the 10K, and this one showing 10 kilohertz. So everything is ready. So I am going to set the power on, right? And then go to the oscilloscope. So I'm going to go to oscilloscope. Oscilloscope is on the top right. This is the oscilloscope. This is the spectrum analyzer. This is the body diagram. And with this one, you go back to the course page. So I'm going to click on the oscilloscope. Oscilloscope popped up. And then I'm going to do some settings, 1 millisecond. I think the settings should be okay. Try to start with no trigger, and then set it to the trigger that lab manual was asking. So let me run it and see what I get here. So after I run it, I see the signal, but I had to just play a little bit with the values here, because even though the laptop is giving you some the settings, but consider this as an oscilloscope that you have to play with settings to see a proper signal. You can see the AM signal right now there, because I have set the the function generator to give me the message signal, and also the oscillator is giving me a signal. These two are going to be modulated together to create the AM output at this point. So let's say, how do I just capture this? So I'm going to right click on the here and say copy, and I'll have to change this to English. Later I'll change it to English. And then if I click on the course page here, I'll go back to course page. If I go down, if I click on this button here, you can see that it popped up on the screen, and then I have it saved here. Then you can answer some question. For example, here, I don't know, there is a question here, describe the measured signal output by the modulator, and let's say I choose this one, right? So I choose it, and then I have option also to check answer, and it says correct. It's funny that I chose it by accident. I didn't even read the question. So that's why I have to ask you later for multiple choices. You need just a little bit of explanation. That's all you need to do. Otherwise, by the end of the lab, you can see that your lab report is getting ready. Again, some more question. So at the end, this principle of AM oscillator experiment is done. After you finish this, you have to save it as a PDF, print, click on print, PDF to PDF, PDF 24, and then it's asking you where do you want to save it. I highly suggest you bring a flash memory, save it to your flash memory, because often the students put it on desktop and then they lose it. Better to have it on flash memory. So there are multiple experiments that you have to do. Then you have to go to the next one. Probably the demodulation is the next one. And that's another PDF file, Let's say you have 4 or 5 PDF files. You have to merge them together, combine them together to create one PDF file. And that's your lab report. So by the time you finish this lab, your lab report is ready. The only thing that you need to add to it is some explanation on the multiple choice. So the same thing that happened, that me, without reading even the question, I was able to answer it correctly. We know that you didn't do the same thing that I did here, and you really understood the question and thought about the right answer. So please don't forget that we do not do all the experiments. We do the experiment based on the lab manuals. So I wish you guys are gonna like this lab for this semester, and we will have a very successful communication lab together. Have a good one. I hope you enjoyed the video.